Hello friends, welcome to Mathspacetech. Today we are going to see an important problem which is called as the Dido's problem. This problem is a specific case of isoperimetric problems. This problem was found by the legendary mathematician who was under the Queen of Carthage who ruled the area of Tunisia before thousands of years. He is called as Dido, under whose name this Dido's problem has been named. This problem was basically concerned with a construction of a capital, a palace for the Queen of Carthage. What was most challenging in this problem was that within any polygon, the queen asked Dido to find the sphere or something, a polygon, so that inside this polygon any other polygonal figure can fit and this polygon might get the maximum area. Why she asked this? She need the capital inside which her palace occupies the maximum area within a small place of a polygon. Mathematically, this law is what is like we need to find a simple closed curve which encloses a maximum surface area inside any polygon. Now, this was named as Dido's problem, and we need to know of the isoperimetric problem rule before doing this problem. What does isoperimetric problem says is like, while you are considering a sphere or some other kind of polygon, tell S, and if you are taking its area to be AER and volume to be VOL and perimeter to be PER, then the isoperimetric problem states like perimeter of S is always greater than or equal to 2 into volume of S power 1 by 2. While you are deriving this showed best result in the case of two-dimensional entity, and for the n-dimensional entity the later mathematicians arrived at a function which is perimeter of S is greater than or equal to n into volume of S power n minus 1 by n. Dido, while he was thinking of the problem, he had an idea of this isoperimetric rule and he started to experiment in the palace which he was trying to place in the small area so that it occupies the maximal surface area. Now he took out the map of the Tunisia and started to plot some figures so that it has maximal area in the polygonal shape. While using this rule perimeter square is greater than or equal to 4 pi into area, he obtained that whenever we take any polygon, not a square, not a triangle, not some other figures like polygons, any polygon does not have a maximal area while you are fitting it inside that. While you are taking a circle, it can be altered in such a way that the radius makes it fit inside the area and obtains the maximum area for that figure. So he now got the result. What it was like a circle which can be fitted into any polygon so that this circle assumes the maximum area as much as possible. Thus, he reported this to the queen and the queen built the palace. This palace is just located in the Tunisian Republic and it is in the city of Carthage, which is a very small city, but it has a very good and a very big palace in a small area in the shape of a rounded sphere. Not only this has the application of isoperimetric or Dido's problem, there are also so many areas in which you would find these applications. Now, I would list one of them. An interesting application of isoperimetric Dido's problem is like in the water droplet or an oil droplet which falls from a certain height. While an oil droplet or a water droplet is falling from the height, it would be in the shape of a symmetric and a circular piece of water droplet or an oil droplet. Now, the force of gravity exerts the force on the top of these two corners of the water droplet and forces the liquids to come down. As a result, the liquid forms a rounded shape within the polygonal shape in which the liquid was already present. That is, the place where the liquid droplet was present remains the same, but the water just occupies the maximal volume as much as possible within the polygon, which is in the shape of a rounded sphere. And this was applied in the concept of oil drop model or liquid drop model. which is very much useful for calculation of volume of electron or power of electrons, also in the case of protons. Okay friends, we have seen about the Dido's problem and the isoperimetric problem in today's video. If you are having some other doubt related to this video, you may comment in the comment section. You may also request me for any such video which you are finding difficulty. Also, you can subscribe to my channel and like and share. Also, don't forget to press the bell icon. Thank you friends.